Welcome, guys. In this question, we, we are going to use work energy theorem. Okay, and in previous lecture I had explained a lot of things. Okay, and give you sufficient background to solve such type of question. It's quite simple question with the you can solve it easily within one or two line with the help of work energy theorem. Okay, guys. Okay, the question is minimum mass of block A so that block B leave the contact with ground. Okay, okay, guys. Initially, block A, sorry. Yeah, initially block A is in rest, and and spring is in its natural length. Okay, guys. So come to the question. Okay, 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 guys. So what happened that due to this force this guy, this block A is coming down. Okay, so let's suppose it's come down by amount x. Okay, guys, let's suppose it's come down by amount x. Let me make x slightly. Yeah, okay, this length is x, this length is x. Okay, guys. Now, so what will be if this block A is come down by amount x, so length of spring is not going to change, so extension in spring, extension in spring is going to be amount x. Okay, guys, because this end move upward by x, so this had to continue. Okay, guys. Now, so okay, so force on spring due to its downward motion of block A will be kx. Okay, guys, kx. Okay, so let me write down this is the x. Okay, this is the x. Okay, now we are going to draw free body diagram of block B. Okay, we are going to draw free body diagram of block A and block B. Okay, block A and block B. Let's draw the free body diagram. Okay, this is the block B, and this is the block A. Okay, B, this is the A. Okay, and it says here mg. Okay, so see here, this mass will be mg. Okay, and this is kx. Who has applied this kx? Spring. Who has applied this kx? Spring. So this block B also apply force on spring by Newton third law. Okay, guys, such type of analysis with spring, applying analysis of Newton third law with spring is very important. Okay, okay, guys. So and this is the n. Okay, who has applied this force? Ground. Okay, this ground has applied this force. Okay, guys. Now, so when I say that block B is just leave the contact. Okay, block B just leave the contact. Okay, so what what happened at point? Okay, when block B just leave the contact. Okay, so here some important concept. Okay, so first thing which is happen is n is equal to 0, because there is no contact, n becomes 0. First thing, guys, and and here you can see here block B is cannot move in this direction. Block B is not moving in this direction, and before leaving, okay, it, the velocity in y direction, velocity in this vertical direction, you can see velocity in this direction is going to be 0. Okay, guys, velocity in this direction is going to be vertical direction. Velocity in vertical direction is going to be this direction. What will be velocity in this direction? It is going to be 0. Okay, okay, guys, and so v will be, v is equal to velocity is equal to 0, vi. Okay, velocity of b is going to be equal 0. Let me write down vv. Okay. Okay, now guys, here we had assumed that the minimum value of b, minimum value of a, so which so which it just block will just leave. Okay, just leave. Okay guys, so it I, I have to calculate that block b just leave the surface. Okay, block b just leave the surface. Okay guys, if x will be greater than amount which is just required to leave the surface, then this block b will getting velocity. Okay, block b will get the velocity. Okay guys, okay, now here, okay, let's think in in more mathematical, more descriptive way. What can I write? Okay, when when b when b leave when b leave. Okay, then va should be equal to 0. Okay, va equal to 0. Okay guys, okay, if you are not able to conclude, if you are not able to think why, then you should think in this manner. I am giving you hint maximum extension maximum extension. Okay guys, maximum force. Okay, maximum force. Okay, and and minimum velocity. Okay, in magnitude. Okay, so you should think about this point, and I hope you get your answer by yourself. Okay guys, when I try to explain a lot of things, you are not able to understand. Okay, so let me explain minimum and analyze it, allowed to analyze you by yourself. Okay guys, okay, so yeah, I am here. Okay, so we had conclude that when block b leave the ground, n is equal to 0, velocity of b is equal to 0, and velocity of a will also be 0. Okay, and here you don't think that here it is 0, velocity of a is equal to 0, because its length of string is not going to change. If you think like so, then you are wrong. Okay, why velocity of a should be 0? It's not because length of string is going to be 0. Sorry, length of string is constant. Okay, okay, now where I am, So we had here. So let's balance it. Okay, here at this point velocity of b is equal to 0. What is the initial velocity is 0. So net force on b, net force on b is 0. Okay, vb is equal to 0, vbi 0. Okay, vbi is equal to 0. So fb net force on b is equal to 0. Why? Okay, you should think about it. Why net force on b? Because vb, final velocity of b is equal to 0, initial velocity of b is equal to 0, so fb net is equal to 0. You should think about why. Okay, now yeah, yeah. So what we get here, x kx is equal to mg. Okay guys, so what is the x is equal to mg by k. Okay, okay. So and now we should think here. Now, is energy is going to be conserved? First question, is energy conserved? Is energy conserved? You should ask this question by yourself. Okay, and if your answer is yes, then this question become one of the most simplest question of this planet. Okay, conserved. Okay, if yes, okay, okay, okay guys. Okay, how you should do it by yourself. Okay, you should think about work done by all possible forces. Okay, work done by all the forces which is in picture. Okay guys, so what is the work done by normal force here? What is the work done by this force? Work done by this is the perpendicular. So work done by whenever this force is in action, displacement of b is going to be 0. So work done by this nb is equal to 0. Work done by this nb is equal to 0. Okay guys, now what is the work done by spring? What is the work done by this string? Okay, work done by string is going to be 0, because work done by spring string on block b is will be negative, and work done by string on this point is going to be positive, and both are equal in magnitude. So net work done by string is going to be 0. Okay, work done by work done by string 0. Work done by string is 0. Okay guys, so you should think about this thing. Why? Okay, find this answer, why the work done by string is going to be 0. Okay, now yeah, so and what is the forces? Spring, you don't know, is force by spring, which is conservative force. Spring, a conservative force, and it is doing work. Okay, conservative force, conservative force. Okay, spring, conservative force. Okay, now work done by okay, and gravity, gravity again, what is this? Is conservative force. Okay guys, conservative force. Okay, now, so only conservative force do work. So guys, only conservative force is doing work. Only do work. Only do work. Okay, only do work. Okay, guys. So that means energy is going to be conserved. So energy is going to be conserved. So energy is going to be conserved. Energy is conserved. Okay. So now, okay. So okay, guys. Now, so we should take some limit. Okay. Sorry, we should take some. Oh yeah. You know, let's suppose at this point. Okay. At this point, you know potential energy is equal to 0. P, gravitational potential, P is equal to 0. Okay, and when string is when spring is in its natural length, its potential energy is 0. So this is the 0. Okay, guys, so let me write down. So let me write down about it. Okay, so E1 is equal to okay, guys, here, see here. Okay, this you know this height, let's suppose this height is h. Okay, let's suppose this height is h. Okay, this height is h. Okay, so initial okay, so initial potential energy will be m a g h. Okay, m a g h. Okay, because work done by work done by gravity in moving from ground to height h will be minus mgh. And so what is the potential energy? Changing potential energy, basically minus of work done by gravity, by conservative force. So due to it, this become positive. Okay, guys, at this point potential energy will be positive. So, and what is the final? E2. Okay, E2 here, spring has some some potential energy half k x, and we had calculated that x is equal to mg by k. X is equal to mg by k, we had calculated it. Okay, so half mg by k square. Okay, guys, plus, and what is the final? Guys, so so when it move downward by amount x, so by amount x, so this height is going to be h minus x. Okay, this height is going to be h minus x. So and the ma g, and height will be h minus x. So okay, this is the problem in you start hanging h minus x. Okay, guys, so and both these two, both e1 and e2 is going to be equal. E1 is equal to e2. Okay, you should think why. Okay, why? You should think why. Okay, guys, now here if you see, what can I write? 1 by 2 k m square g square. Okay, plus ma sorry guys, this is not k, by k. Okay, mag h minus mag x is equal to e1, which is mag h. Okay guys, so this 2 is going to be cancelled out. Okay, so if you look at this, if you look at this, what you find that half mg by k, half mg by k, m square, sorry, m square g by k, half m square g by k is equal to is equal to m. Okay, and what is the x? Oh, pardon me guys, m x. What is the x? X is equal to m g by k. Okay, m g by k. Okay guys, what is rubbish I am doing right now? What is this? Hmm? Okay guys, so yeah, so g and g will be going to cancel out. Okay, and k is also going to be cancel out, and so what we get here after doing that, m by 2 is equal to ma. Okay, m by 2 is equal to ma. Okay guys, so ma is equal to m by 2. Okay, so this is the guys, here it is a very important thing, guys. If you become an engineer, okay, if you become an engineer, guys, so you, and if you wanted to lift some very heavy thing, okay, you know otherwise, if you have to design a structure, if you wanted to lift very heavy thing with the help of a simple machine, okay, with the help of a simple machine, guys, we you can lift, you can lift you can lift this this block b with half of its mass. Okay, okay guys, this means if you use this spring, then you can lift this block b by mass which is half of block b. Okay, so this is the very important in designing problem. Such type of question is very very important. Okay, okay guys, if you like this lecture, then subscribe my channel and like my videos and share it among your friends. Thanks for watching.